morning, students. Now we'll start the next concept here, that is basic properties of charges. This will be the first property is irritivity of charges. So we know the charges are just we can treat like mass. So why? Because charge and mass both are scalars. The difference is these are both positive and negative, but masses is always positive. So charges can be added. How the masses can be added algebraically, the charges also can be added algebraically. Let, without taking any vector rules, let q1, q2, q3 and so on, qn are the charges. Then net charge, we can take it as a q net is equals to, just we can take the algebraic summation, that is q1 plus q2 and so on qn. The same way, but if it is any one positive and negative sign is there, we have to be take that sign convention as it is. Like that, if you take if a system is consisting of the charges plus 2 microcoulomb minus 3 microcoulomb and 5 microcoulomb, like that is there, then we can add the net charge. In this case is q net is equals to, we can write here 4 microcoulomb, that is plus 2 minus 3 and plus 5, that is 4 plus 4 microcoulomb charge. So this is generally we can take it as a additive of charges. And next one is charge is conservative. What is the meaning of charge is conservative? Is charge is conserved. The meaning of charge is conserved means the isolated system, the total charge of the isolated system is always conserved. The total charge of isolated system is always conserved. Meaning is the charge is neither created nor destroyed. It is not possible to create or destroy the net charge of an isolated system. So it is not possible to create or destroy net charge. So charge will be cannot be created or we cannot be destroy it, but we can transfer it from one body to another body. So charge developing in the sense that is one body lost it and the other body is gains, but we are not creating a new charge, we are not destroying the existing charge. That is nothing but charge conserved. Next one is the charge quantized. What is the meaning of charge quantized here? Charge quantized. The charge quantized in the sense we discussed that in this property charge conserved in the sense charge will be transferred from one body to another body. So charge quantized in the sense we can say charge is always transferred as an integral multiple of charge of an electron. That is, electron is the fundamental charge, we know. So the charge will be transferred from one body to another body as an integral multiple of fundamental charge called electron here. So charges be transferred, charge always transferred as an integral multiple of charge of an electron. That is a fundamental charge of electron. That is, we can write charge is nothing but we can take it as a plus or minus Ne. Here N is an integer. That is N is equals to 1, 2, 3 and so on. Means if it is lost electrons, will take Q is equals to plus Ne. If it is gains electron, excess of electrons means that it will take it as a Q is equals to minus Ne. Charge is always be like a integral multiple of whole numbers here, but it is not the fractional like 1 by 3 or 2 by 4 like that, 3 by 5 like that. It is always existing in this form only. Here we can understand that one example. If you take if a body is 1 coulomb of charge it is having, let us take if a body is having plus 1 coulomb of charge it is having. So plus 1 coulomb of charge it is having means we can write as plus 1 coulomb of charge. Then we can understand how many electrons are present in it. How many electrons present, or how many electrons here positive show, how many electrons lost by it. So you can understand that how many electrons are lost by it. We can take by conservation of charge. You know Q equal to plus Ne. Then we have to find the how many electrons lost means N we need to be determine it. Here N is equals to Q by E. Then you have Q here is 1 coulomb by electron charge is 1.6 into 10 raised to minus 19. That is nearly 6.25 10 raised to 18 electrons. So these many electrons if the body lost, it acquires 1 coulomb charge. It acquires 1 coulomb charge. Then so we can take that if the body is lost these many 6.25 10 raised to 18 electrons, we say it is 1 coulomb charge it is acquired. Next one, charge is invariant. So charge is invariant in the sense the next property, charge is invariant. The meaning is invariant means if any body if it is in motion, if it is changes like mass if you taken, if it is in motion its magnitude is keep on increases according to relativistic mechanics. Its magnitude is keep on increases. But if charge is invariant, meaning is if charge is at rest or else if the charge is in motion, its magnitude remains the same. So if charge is at rest or in motion, its magnitude remains same. So we can understand that. But mass invariant means you can take mass is variant. Why it is variant mass? In the sense if the mass is in motion, mass m is equals to rest mass m naught by under root of 1 minus v square by c square. So velocity, if cosine increases, what will happen means the mass is going to be increases. Here m0 is the rest mass. If if v equal to c, if it is becomes if v equal to c becomes m is equals to infinity, so the mass becomes infinity, means you can understand if the mass continuously increases, the speed of the mass is increasing. So that is the thing you can understand. If it is reaches to velocity of light, almost its mass is becomes infinite. So but charge is not like that. If the charge, if it is at rest, if charge even if it is in motion also, its magnitude never changes, it will be remains same. That is, we can call it as a what, charge invariant point, invariant property. Next we can discuss the what some points here. We know charges are there, uh, like charges repel each other, or unlike charges attracts. And one more thing, the charges is in motion, it is only exhibits electrical property if charge is in rest. It only exhibit electrical effects. So if it is a charge, if it is in motion, it exhibit electric and magnetic. The charge is accelerating, it exhibit it is produces the EM radiation, electromagnetic radiation. So if the charge is rest, it is produces electrical effect. If it is in motion, it produces both electrical and as well as the magnetic effect. And if it is accelerating, it produces the electromagnetic radiation. That is, we will be discussed in electromagnetic radiation topic, how electromagnetic radiation is produces and all. Now we can go further. One example on basis of this one. If you take a cup of water, so if you take a cup of water, so in that cup of water, so how much of positive charge is there? So how much of positive charge as well as negative charge is present in a cup of water? So example, we are discussing that. So how much of positive and negative charge is present in a cup of water? So how much of positive or negative charge present in a cup of water? We know cup of water in the sense, usually generally one cup of means it is nothing but 250 grams. One cup of water is nothing but of water is nothing but 250 grams, you can say almost 250 ml, that is 250 grams here. So we can take that how much of charge is present in the sense, first of all you have to know water structure. You know water in the sense, how much of positive in the water, that is H2O. So in this H2O, how many atoms are present? You have to understand. Atoms means you can know by knowing it, how many moles of substance is present in this 250 grams. So 1 mole of substance is consisting of Avogadro number. Then we can get from that how many positive charge, how much of negative charge it is having. So number of moles here, and it is mass number or atomic mass or molar mass, we can write. Molar mass is 18, so 18 grams. So first we will be discuss the number of moles. Here number of moles is equals to given mass by molar mass, that is given mass is 250 grams by molar mass is 18. This is number of moles. And in 1 mole consisting of 1 mole is consisting of 6.023 10 raised 6.25 10 raised to, we have 23, 6.023 10 raised to 23. atoms will be present. In these number of moles, number of atoms present in number of atoms in 250 grams of water, that is number of moles into number of atoms present in 1 mole, that is 6.023 into 10 raised to 23. So these are the number of atoms. You can observe H2O in this hydrogen. Two hydrogens are there. In hydrogen, in hydrogen we have one proton plus one electron. In oxygen, we know 8 protons plus 8 electrons. So here two hydrogens are there. Two hydrogen in the sense 2. I means 2 protons plus 8 protons. That is totally, or else we can take 2 electrons plus 8 electrons. So in totally H2O we have 10 protons as well as 10 electrons. If you want it how much positive charge in the sense protons, you will take it. If you want it negative charge in the sense equal same magnitude of negative charge is present. So total charge is nothing but these are the number of atoms, and in each atom 10 protons means this into this one, if you multiply then you will get the total number of charges present in it. Therefore the total positive charge is nothing but we can write as a, therefore total charge is equals to N E. Here plus we are taking positive charge dimension. Here number of proton means number of positive charges. So number of electrons are here, number how many were present in this means number of moles into, so number of mole into nothing but Avogadro number, and if you multiply with 10, so total number of positive charges present we can get it. So that is 250 by 18 into 6.023 10 raised to 23 into in each atom 10 protons, and charge of the proton is 1.6 into 10 raised to minus 19. Then if you calculate the, you can get the nearly 1.34 into 10 raised to 7 coulomb of charge, you will get it. So like this according to quantization of charge, here we use the simple principle, that is quantization of charge. So in any given substance, number of atoms present into, so that atom how much of positive charge is consisting or negative charge. So this much of positive as well as negative charge it will be consisting, because how much in neutral body how many positive charge is there, same amount of negative charge is there. Here 10 protons as well as 10 electrons. So total number of atoms into, this is the total number of atoms, and this is the each atom present how many positive charge into the one positive charge is consisting of 1.6 10 raised to minus 19 coulomb. So that is we multiplied, we got this much of charge is consisting in the 1 cup of water. Now we can go for the another important law, that is Coulombs law, or we can say Coulombs inverse square law. So Coulombs law, this is very important. So we can say the electric force between charged objects were measured, means the quantitatively we can measure the force between the charges by the law called, what we can say, this is Coulombs law, and this force is along the line joining the two charges. The force between the two charges, whether it is attractive in nature or repulsive in nature, the force between the charges, the force between the charges is F. Suppose if you take a charge Q1, if you take a charge Q2, and if these two separation is R, So the force between these are like charges, so force of repulsion. This force of repulsion is directly proportional to the product of their charges and inversely proportional to the square of the distance between them. This is the thing you observed in the what gravitation. If two masses were there, the force of attraction between the two masses is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. In the same way here, between the two charges, the force is directly proportional to the product of their charges and inversely proportional to the square of the distance between them. Then if you take the proportionality, you can write F uh, is equals to some constant k into what, q1 q2 by r square. Here this constant k is nothing but a proportionality constant. Here this k is equal to 1 upon 4 pi epsilon naught. So where epsilon naught is nothing but permittivity of free space. What is the meaning of permittivity of free space? Means it is the property of the medium which influences the force between the charges. If this other than this free space is there, the force will be effective, means changes here from if it is different medium, so the force will be different. But in a gravitational law, if you observe that two masses are there, if it is intervening medium is different, also the forces remain the same. But in Coulombs law, the force between the charges is not like that. If the force between the charges changes from medium to medium, so the medium and the medium which affects this force, so that is called permittivity. So for air we take permittivity as epsilon naught and its value is 8.85 into, you can take it as a 10 raised to 10 raised to minus 12. So we can understand here Coulomb F is equals to, we can write 1 upon 4 pi epsilon naught q1 q2 by r square. Epsilon naught in the sense you can write if it is comes this side, Coulomb into Coulomb square by, here r square means meter square, force will come down, so Newton meter square is the unit. You can understand that. Suppose if it is other than this free space, and if you the force is going to be change, so this epsilon naught value, if you substitute in this constant k equal to 1 by 4 pi epsilon naught, this epsilon naught if you substitute here, you will get this as 9 into 10 power 9. So 9 into 10 power 9, you will get it here as the what, the proportionality constant. Then you can say this 9 or 10 power 9 in the sense Newton meter square per Coulomb square. This is the thing. Suppose if you can understand here in air, if charges one is 10 microcoulomb, another one is 8 microcoulomb is there, and if it is distance is 1 meter, if it is separated, if air is a medium, so air is a medium in the sense F here air as a medium, so F in air is equals to, we can write 1 upon 4 pi epsilon naught q1 q2 by r square. So that is 9 into 10 power 9 into q1 q2 means 80 into 10 raised to minus 12 by 1 square. So if it is air means you can write like this. But is in other than air means in water, if you take it, so in water means epsilon value is different. Epsilon value how it is means epsilon in water is nothing but 80. So here means dielectric constant, dielectric constant in A is 1 by 80. So this is will be force. Then we can calculate this amount of force in air, that is equal to what we can write, 720 into 10 raised to minus 3 newtons, or else you can write 0.72 newtons. Like this you can able to calculate the force. Next we can go for the relative permittivity, or permittivity of the medium. Here permittivity of medium. So the property, you can say here permittivity what we are discussed in this law, and that property of the medium which influences the force between the charges, that influences the force between the charges is called as the permittivity of the medium. And the medium which influences the which influences the force between the charges, and you can say the proportionality constant from the 1 upon 4 pi epsilon naught q1 q2 by r square. Here epsilon naught is there means it is in air present. If it is in medium means you can write 1 upon 4 pi epsilon. Okay, so epsilon naught is related to the free space or air or vacuum. We can say here epsilon is nothing but for the medium, that is q1 q2 by r square, where epsilon is the permittivity of medium. Then you can write as this is f air 2. So f air 2, f medium is there, that if you write, you can write as remaining all will be cancelled, so 1 by epsilon naught by 1 by epsilon, then you get epsilon by epsilon naught, that is permittivity of the medium to permittivity of free space. So permittivity of medium to permittivity of free space or vacuum. This is we can call it as a k in the sense dielectric constant also. So or we can also call it as a relative permittivity. So this is relative permittivity in the sense you can understand it is the ratio of permittivity of the medium to the permittivity of vacuum. So epsilon r, or we can say k. This is relative permittivity, or also you can call it as a dielectric constant. Then if you understand that if the dielectric constants for different mediums are different, so k value, or you can also write epsilon means epsilon r means you can write epsilon by epsilon naught, then epsilon equal to epsilon r k epsilon naught, then epsilon r also we can write as a k epsilon naught, means where k is the dielectric constant. So and f in A2, f in medium you got as a dielectric constant from this expression. Then f in medium is equals to f in air by k, means if the medium is present between the two charges, then the force when they are present in air, that force reduces by k times. For example, if charges q1 q2 is there, if it is a distance separation is r, so let us suppose if it is their experiences some force F is equals to in air is there, their experiences some 80 newtons. If air is there, then 80 newtons force they're experiencing. So in water if they place those, in water dielectric constant is 80. So water dielectric constant is 80, and and here we are not having any units because it is we are taking as the what ratio of two similar same quantities, same physical quantities. So 80. Then how much of force now they will experience these two charges? Then we can understand F in water is equals to F in air by dielectric constant of water. F in air they are experiencing 80 Newton by dielectric constant of water is 80. Then the force now reduces to 1 Newton. So you can observe when it is in air it is experiencing 80 Newtons, but when you kept inside those charges, if you place inside the water and maintaining the same distance, the force reduces to 1 Newton. So if the medium changes, the force is going to be effective. Means the force reduces by how many times it is reduces, in the sense dielectric constant times. Dielectric constant times the force is going to be reduced when they are present in the what air. So this is the thing you should be understand clearly. So permittivity of the medium means it is the medium which influences the forces, and also you can understand. So if the medium changes, the force is going to be reduced. How many times reduces means, so that is based on it relative permittivity, or else we are calling as a dielectric constant. So medium changes, the force going to be reduces to dielectric constant times. That is the thing you can understand. Next we can go for this. What is the differences? Usually here main intention is Coulombs law in vector form. That is also very important. Coulombs law in vector form, and we discussed that Coulombs law is the force between the two charges, and that qualitatively to know the magnitude of force we will take the Coulombs law, and its direction is along the line joining the two charges. Let us take what is the what force in vector form. How this Coulombs law can be understand here is, if you take the coordinate system like this, here charge q1, here charge q2, and this position vector is r1, and this position vector is r2.